All right, what's going on, y'all? This one is 212. Same rules, right? Nodal displacements, forces in each element, and reactions. Direct stiffness method. We got 3 springs here, so we're gonna have a 3x3 matrix. These problems are somewhat longer, but it's all good. Let's go ahead and get started. Okay, so we got 4 nodes, right? 1, 2, 3, 4. So that means we're gonna have a 4x4 matrix. Let's do step 1, and there's going to be 4 forces, 4 reactions at each node. So force 2x, force 3x, force 4x. And again, our main goal is finding the force vector, which is this one. And that is equal to the global stiffness matrix times the displacement vector. Okay, so that's the main goal. So this is the force vector. And then let's go ahead and get started on the stiffness matrix. All right, so it's going to be nodes 1, node 2, node 3, and 4. Then we're going to put node 1, 2, 3, and 4. And then the displacement vector. So it's going to be U1, U2, U3, and U4. All right, so let's do the first spring. So we got to fill in this table. Let's, it's not going to be the springs aren't identical in terms of stiffness, so the values are going to be kind of, not weird, but just not equal, if that makes sense. So this one's between nodes 1 and 2. So that means we're going to be focused on position 1, 1, 1, 2, 2, 1, 2, 2. And that those numbers are 10,000, 3, negative 10,000, negative 10,000, and 10,000. Okay, and this one is between, you could, since all these are in the thousands, right? Or you could factor out 10,000 and put it out here, and so you'll have 1, negative 1, negative 1, 1, but I like to keep it all in whatever number they give us. So in this case, I'll keep them in tens of thousands. So second one is between nodes 2 and 3. So that's position 2, 2, 2, 3, 3, 2, 3, 3. And we're going to add 30,000 to all those positions. Well, it's going to be 30,000 added to this one. That's going to be 4,000. It's going to be negative 10,000 here because negative 10,000 plus 0 is just negative 10,000. Then we got negative 10,000 here and 10,000. So you see that, right? So here it was 10, 10, 10, 10. Or, okay, you know what? It was 10, negative 10, negative 10, 10. And then it's 3, negative, or I'm sorry, 30, negative 30, negative 30, and 30. Wow, good thing I went back. These are 3s right here. So it's negative 30,000, 30,000, and 30,000 here. There we go. So again, my bad. So it's, since this was the first spring, it's 10, negative 10, negative 10, 10. Then when you add the 30, it becomes 40. So it's technically 30, right? Negative 30, negative 30, 30. Then the next one is positions 3 and 4. I mean the nodes 3 and 4. So it's going to be 3, 3, 3, 4, 4, 3, 4, 4. And we're going to add 10,000. So this one's going to become a 40,000. This is going to be a negative 10,000, another negative 10,000, and 10,000. Hope I didn't confuse you, but if you're still confused on how to do these matrices, just go back and watch any other video. I think in each video I explain it just to make sure. But now that we got the global stiffness, we could go ahead and start doing the boundary conditions and the loads, and then we could start solving for variables. So let's see. U1, that's not moving. That's at the wall. And U4, same thing. So these are going to be 0 right here. Okay, so 0, 0. There's a force at 2. And then obviously if you apply force here, so 2 and 3 are going to move. So we're looking for these two. There's going to be a, if you apply a force at 2, it's a positive 450. So we got that one. There's no force at 3, right? There's nothing going on at 3. It's kind of just moving with the flow. So that's going to be 0 and positive 450 at node 2. There's a force at 1 and then there's a force at 2. Now, if you have 450 going to the right and nothing acting here, that means these two, the force has to total 450 to the left. Now, it doesn't necessarily mean they're equal. This is going to be 225 or 225. That's not the case. It just means it has to be equal and opposite to this, right? Equilibrium, sum of the forces in the x. And this is our positive x direction. All right, so we could go ahead and continue with the equations to solve for the unknowns. So f1x is equal to 10,000 times 0 minus 10,000 u2. 10,000 u2. 0, 0, so these go away. 450, next one, is equal to negative 10,000 times 0 plus 40,000 times u2. 40,000 u2 minus 30,000 u3. 30,000 u3. Okay, next one, 0 is equal to 0 times 0, that's 0. Negative 30,000 times u2, that is negative 30,000 u2 plus 40,000 u3 plus 40,000 u3 minus 10,000 times 0. Last one, f4x is equal to 0, 0, negative 10,000 u3, 0. So just negative 10,000 u3. All right, so again, 4 equations, 4 unknowns. Now, if you have that calculator, the fancy one that gives you, that could do the matrices, and if your professor lets you, then yeah, go ahead and use it. But I like to solve things by hand because my calculator sucks. It's just a basic scientific $15 calculator. You never want to focus on the equations where you don't know force. Again, you always find displacements first. So that means just these 2 equations. You got 2 equations, 2 unknowns, u2 and u3. So let's go ahead and do step 3. Now, there's 2 ways you could tackle this. You could, equation 2 and 3, you could multiply the top by, let's say, find a common denominator, right? So we want to reach 12,000. You'll multiply the top by 4 because the goal would be to cancel one of the variables out. You'll have this times 12 equals this times 12 equals this times 12, which is negative 12,000 u3. And then multiply the bottom equation by 12 again. You'll have this times 12, this times 12, and this times 12, but this would be 12,000 u3. The 12,000 u3 will cancel out with this negative once you add the 2 equations, and you could solve for u2. But I'm not going to do that, just to show you another way. I mean, it's not really showing you another way if you saw the other videos, but it's just solving for one of the variables in any of the equations. In this case, I'm going to use this one because this 450 is a little extra. This one's 0, so I could just move it here. It'll become easier. So let's stick with equation 3. It's 3,000 u2 is equal to 30,000 is equal to 40,000 u3. So I'm going to divide both sides by 30,000 and I'll get u2 is equal to 1.333 u3. So that's not the answer. That's just a relationship. So I'm going to use this relationship to plug it into equation 2. So this was equation 3, right? I just moved it here, divided by 30,000. Now I'm going to plug this right into here. So I'm going to have everything in terms of u3, and then I can solve for it. So I'll have 450 is equal to 40,000, 1, 2, 3, U2, but U2 is 1.33 U3, right? Just plugged it in, made the substitution. Minus 30,000 U3. All right, if you multiply this, you'll get 53,333. That minus 30,000, you will get 450 is equal to 23,333 U3. Okay, solve for U3. You will get, I already did all the calculations, just FYI, 0.193 meters. So that's the answer for U3. Okay. Plug this number into U2 right here, in this equation. You could solve U2. U2 is equal to 0.0257 meters. So we got both displacements that were unknown. Now that we have these two U's, we could find F1x using U2 and then F4x using U3. So step 6, F of 1x is equal to, plug in this number right here into, or multiply this by negative 10,000. F1x will be negative 257 newtons going to the right. That just means positive 257 going to the left, but I'll keep it like this for now. Again, it's always good to put the arrows, because if you don't know how to communicate this negative later, you're screwed. Now we can solve F4x, plug in U3 into this one right here, times negative 10,000. So F4x is equal to negative 193 newtons going this way. Cool, so we can verify now. Remember I told you that there's no force at 3, so the sum of the forces at 1 and 4 have to equal 450, but in the opposite direction. Well, that's true. If we got 450 going to the right, and 193 going to the left, and 257 going to the left, add these two up, you get 450. That means we did something correct. All right, so we're good on that piece. We found all the forces, all the displacements. Now let's find the forces in each element. So step 8, first element is between nodes 1 and 2. So force 1x, force 2x, right? The stiffness matrix is a 2x2 and its value is 10,000. Negative 10,000, negative 10,000, and 10,000. Displacement vector is U1, U2. That U1 and U2, well, U2 is right here, 0.0257. U1 is 0, right, fixed. So that means we could solve the elements, the local force elements for element 1. It's 10,000 times 0 minus 10,000 times this. That is negative 257 newtons going this way. F2x of element 1 is equal to positive. Same thing, right? Negative 10 times 0, that's 0. 10,000 times this, that is 257 newtons going this way. All of them will be going this way, assuming you don't switch the sign, just FYI. So that's the first answer. Well, for the first element, we got to do this 2 more times for each spring. So now, next one. This spring is between nodes 2 and 3, so it's F2x, F3x. That is equal to the 2x2. The value is 30,000 for this spring. So it is negative 30, 1, 2, 3, negative 30, 1, 2, 3, 30, 1, 2, 3, 30, 1, 2, 3. Displacement is U2 and U3, right? Because it's between 2 and 3. So U2 is 0.0257. And node 3 moves 193, 0.0193. All right, cool. So F2x of element 2 is equal to 30 racks times 0.0257. That is 771 minus, right, because it's negative, 30,000 times 0.0193. That is 579. And that means F2x of element 2 is equal to 192 newtons going this way. Let's do F3 now. F3 of element 2 is equal to, same numbers, just sign switched. So it's negative 771 plus 579. That's going to be F3x of element 2 is equal to negative 192 newtons going this way. So that's the answer right there. Now, 192 is obviously not equal to the 193 here, but that's only because we rounded this number. If you would have left the 0.025, I think this was 6 something 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 something, you'll get 193. But we're off by 1 newton, so we're fine. Finally, the last one, it's between nodes 3 and 4, and the value is 10,000. So that is F3x, F4x, right? Value is 10,000, so it's negative 10,000, 10,000, negative 10,000, 10,000. And that vector for displacement is U3 and U4. So it is 0.0193 and 0. U3 and U4. All right, we're almost there. Force 3x of element 3, the third spring, is 10,000 times this, which is 193 newtons. Minus 10,000 times 0, it's 0. So that's the answer going this way. Again, all of them are pointing to the right. As long as we don't change the signs, they're all pointing to the right. F4x of element 3. Oh, damn it, it's going to bother me. 3 is equal to negative 10,000 times that, and then 10,000 times 0, so this is just negative 193 newtons going this way. So let's verify them. Again, you could always check. That's the cool thing about this subject. Everything has to like cancel out or match. So in our original force vector, it's force 1x, which is negative 257, right? 450, 0, and F4x, which is negative 193. So that means for F1x, we have to add all the F1x's here, and that should total negative 257 that we got here. So let's do it. F1x right here, negative 257. Does F1x come up here? Nope, 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 nope. Boom, negative 257. Got the first one. The F2x's have to add up to 450, okay? So we got an F2x here, that's 257, okay. Got an F2x here, that's 192. Add them up, you get 449, which is 450. Again, we're off by 1 newton. We're all good. F2x, nope, 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 nothing else. So cool, they add up to 450. That means we did something right, okay. F3x is 0. So add up all the F3s here. None here, none here, none here. One right here, negative 192. F3x right here, 193. Add them. In this case, you just get 1 newton, right? 193 minus 192, but again, that's only because of the rounding error. And yeah, that's 0 pretty much. So F3x is 0 indeed. So we got it. And finally, F4x is negative 193. F4x doesn't appear here, except right here, negative 193. We did it right. So that's the answer to the problem. That's the bottom, and this is the top. I hope they helped, and we're good to go to the next one.